Hello sir, this is Shoaib Khan from Mechanical Engineering. My roll number is 234G1A0329. Today my topic is Bezier and B-spline curves. Subject CAD CAM. Bezier and B-spline curves. Introduction to Bezier and B-spline curves. Bezier and B-spline curves are fundamental tools in computer graphics and geometric modeling. They are used to create smooth, flexible curves in various design applications. Understanding their properties helps in designing complex shapes efficiently. As shown in this figure, Bezier curve. Overview of Bezier curves. Bezier curves are parametric curves defined by a set of control points. They are widely used due to their simplicity and initiative control. The curve shape is influenced directly by its control points. Basic properties of Bezier curves. The curve always starts at the first control point and ends at the last control point. Bezier curves are contained within the convex hull of their control points. They are invariant under affine transformations like translation, scaling, and rotation. Mathematically representation of Bezier curves. Bezier curves are expressed using Bredesen polynomials. A degree n Bezier curve is defined by n plus 1 control points. The curve equation is weighted by sum of control points with Bredesen basis function. The Castel-Juice algorithm. The Castel-Juice algorithm provides a recursive method to evaluate Bezier curves. It involves linear interpolation between control points. This algorithm is numerically stable and useful for rendering and subdivision. Limitations of Bezier curves. Bezier curves are limited in modeling complex multi-part shapes smoothly. Increasing the degree for complex shapes can lead to numerically instability. The lack local control, moving one control point affects the entire curve, as shown in this figure. Introduction to B-spline curves. B-spline curves generalize Bezier curves with greater flexibility. They are defined by a set of control points, a degree, and a knot vector. B-splines allow for local control and complex modeling. Control points and knots in B-splines. Control points involves the shape of the B-spline curve. The knot vector determines how control points affect the curve. Uniform open and non-uniform knot vectors affect the vector properties. Mathematically formalization of B-splines. B-spline curves are expressed as a linear combination of basis functions. Basis functions are defined recursively using the Cox-Doe recursion formula. The degree of the B-spline and the knot vector shape the curve. Properties of B-spline curves. B-splines are piecewise polynomial with local control. They are non-negative and form a partition of unity. They can be refined without changing the overall shape via knot insertion. Difference between Bezier and B-spline curves. Bezier curves are defined by a single set of control points while B-spline uses multiple. B-spline offer greaterly flexibility and local control compared to Bezier curves. Bezier curves are a special case of B-splines with a specific knot vector. Applications of Bezier curves. Bezier curves are used in vector graphic design, font creation, and animation. They are fundamentally in CAD software for designing smooth curves. Bezier curves are also employed in motion paths and user interface design. Applications of B-spline curves. B-spline curves are used in computer-aided design and 3D modeling. They enables the creation of complex, smooth surface like nerves. B-spline are essential in animation, robotics of path planning. Advantages of Bezier curves. Bezier curves are easy to understand and implement. They provide predictable and smooth curve shapes. They are ideal for simple controlled curve design. Advantages of B-spline curves. B-spline allows for local control of the curve shape. They can easily handle complex and large data sets. B-spline can be refined and manipulated without global changes. Limitations of B-spline curves. B-spline curve require more complex calculations compared to Bezier curves. They can be less intuitive to control without understanding knot vector. Designing specific curve shapes may be require careful knot vector adjustments. Practical consideration in design. Choice between Bezier and B-spline depends on the complexity of the shape. Control point placement is critical for achieving desired shapes. Software tools often provide interactive interfaces and manipulating both curves. Visual comparison of Bezier and B-spline curves. Bezier curves are smooth and easy to manipulate with few control points. B-spline provide more flexibility with multiple control points and local editing. Both types can produce similar shapes but different in control and complexity. Summary of key concepts. Bezier curves are simple with a global control and easy to implement. B-splines are more versatile, offering local control and handling complex shapes. Understanding their properties allows for a better application in design modeling. Conclusion and further reading. Both Bezier and B-spline curves are essential in modern computer graphics. Mastery of the properties enables advanced modeling and animation techniques. For further learning, explore resources on nerves, curve fitting, and advanced geometric modeling. Thank you. Thank you for watching.